In this video, we are going to discuss about the bubble sort algorithm. This is the sorting algorithm that we can use to sort the array. So here in this video, we are going to discuss about this bubble sort algorithm theoretically, and also we'll write the algorithm for it. And in the end, we will try to implement this bubble sort algorithm in Visual Studio Code, and that is also using the Java language. Okay, so let me just first start with bubble sort algorithm, that how we can sort the array theoretically. First, we will discuss. Okay, so we have one array, integer array of size 5, and I'm storing integer values 50, 40, 30, 20, and 10 inside this. And I want to sort this array in ascending order. So 10, 20, 30, 40, and 50. Okay, so before starting it, what we have right now, we have 50, 40, 30, 20, and 10. Yes, and let me tell you one thing. In bubble sort algorithm, we will compare each element with its next immediate adjacent element. Okay, so here I am comparing this element at index 0 with its next element, which is at index 1. And now we will check if 50 is greater than 40. Yes, this condition is true. Then what we will do? We will swap those two elements. So here 50 is greater than 40. So we will swap these two elements. So it will be 40, 50, 30, 20, and 10. Now next we will compare elements at index 1 and 2. So here again 50 is greater than 30, so we have to swap these two elements. 40, 30, we are swapping these two. So here 50, 20, and 10. Now again we will compare elements at index 2 and 3. So here I can see the 50 is again greater than 20. So again we will swap these two elements, 40, 30, 20, 50, and 10. Now again we will compare elements at index 3 and 4. So here 50 is greater than 10. So again we'll swap these two elements, 40, 30, 20, 10, and 50. Okay, so now you can see that this element at its correct position right now. So now you can see one thing that now you can notice one thing that the element at the last position has the correct value. Okay, so now we don't need to touch this element. We'll just try to sort this elements. Okay, so let's do that. So what do we have right now? It's 40, 30, 20, 10, and 50. So we'll again compare these two elements at index 0 and 1. So 40 is greater than 30, so we'll swap these two elements. Okay. Now again we'll compare these two elements at index 1 and 2. And here 40 is greater than 20, so we have to swap those two elements, 10 and 50. Now we'll compare elements at index 2 and 3. So 40 is greater than 10, then we have to swap these two elements as well. So now one more thing you must be noticing, that element at index 3 is correct. Okay, so now we also no need to touch this elements. We will only try to sort this 3 elements. So what we have right now, we have 30, 20, 10, 40, and 50. So we are comparing these two elements at index 0 and 1. So 30 is greater than 20. So yep, we will sort this two, swap these two elements. Now we'll compare elements at index 1 and 2. So 30 is greater than 10. So we have to swap 10 and 30. So now you must be noticing that element at index 2 is correct. So we don't need to touch this element. Now we just try to sort these two elements. Okay. So what do we have right now? So it is 20, 10, 30, 40, and 50. So we'll compare these two elements at index 0 and 1. So 20 is greater than 10. Then we'll swap these two elements 10 and 20, 30, 40, and 50. So now element at index 1 is correct. We don't need to touch this element. Even we don't even need to touch this element because all the other elements are at the correct position. So definitely this is also at the correct position. So now you can say the array is in the sorted manner. Okay, so let's first try to write the algorithm. So for I is equal to how many times we are running this outer loop. So I can say 1, 2, 3, and 4. The size of the array is 5. So 5 minus 1. So for I is equal to 0, I should be less than array size minus 1 and I plus plus. So for inner loop, for j is equal to 0 to j is less than array size minus 1 minus I and j plus plus. We'll come to this why we wrote this particular value here. So what we are doing inside this loop, we are comparing each element with its next element. Okay. So if array of j is greater than array of j plus 1. Okay. Then we will swap array of j and array of j plus 1. Okay. So let's come to this. Why we wrote this particular value here. So here you must have noticed that here we are comparing the value how many times? 1, 2, 3, and 4. In the next iteration, 1, 2, 3. In the next iteration, 1, 2. And here only one time. So the count of comparison is getting decreased. The reason is because at the end of each iteration, at least one element is getting its correct position. Okay. So here let's consider that for I is equal to 0, the j value could be 0 to 0 and j is less than array size is 5 minus 1 minus I is equal to 0. So j is less than 4. So possible values for j is 0, 1, 2 and 3. Okay. So here you must be saying for I is equal to 0, possible values for j 0, 1, 2 and 3. Okay. So now let's check for I is equal to 1. So j is equal to 0 and j is less than array size minus 1 minus I. So array size is 5 minus 1 and minus I. The value of I is 1. So it is 3. So j is less than 3. So possible values for j is 0, 1 and 2. So here also I can see 0, 1 and 2. So it is proved that this is the correct value. So here I have just created one sample program to demonstrate the bubble sort algorithm. So here you can see I have created one integer array. The name of the array is scores, and I am storing these values inside this array 50, 40, 30, 20, and 10. And here I have created one more function which is called print scores. So it will just print the values that I have stored inside the array. Okay, and here it is the bubble sort algorithm. I'm calling this bubble sort function that will sort this array. The main function of the bubble sort algorithm we have to write here. So as we discussed, the outer loop I is equal to 0. We are starting the loop from 0. Then I is less than, what is our array name? It is course dot length minus 1, then I plus plus. Okay. Now, sorry, I missed to declare it integer. Now the inner loop for integer j equal to 0, then j is less than scores dot length minus 1 minus I and j plus plus. So here we'll first check if scores of j which is greater than scores of j plus 1, then we have to swap those two elements. Okay. So for the swapping as well, I have created one function. So swap. So here I am passing the scores. Here I have to pass the index of the elements that I want to swap. So I want to swap the values at index j and the value at index j plus 1. So what this swap function will do, it will just swap those two values in the array. Okay, so let's just try to run this. Good. And let me first compile this. Okay, and now let's run it. So before sorting this array, you can see I have called this print scores function to print the scores value of this scores array. So it is 40, 50, 30, 20, and 10. Same as what we created. And even after sorting the array, means we call the bubble sort function that must have sort this array, and then again we are printing the scores array. So now you can see it is in the ascending sorted order. So this is about the bubble sort algorithm. Thank you.